better place. We are smart at what we do to make our world a better place. By the help of God, to make our world a better place. By the help of God, to make our world a better place. Smart do.
Hello students, welcome to our session. We are going to discuss thermochemistry, topic heat of dissolution or enthalpy of dissolution. Now dissolution comes where a substance dissolves in a solvent, or a solid dissolves in a solvent to form an infinitely well solution, or to form a solution. Now, in this topic, we are going to find out how do you calculate the enthalpy of dissolution. We are going to use a sample question for that. The question is, when 2 grams of sodium hydroxide are dissolved in 100 cubic centimeters of water, the temperature of the solution lowers from 26 degrees to 24 degrees. When 2 grams of sodium hydroxide are dissolved in 100 cubic centimeters of water, the temperature of the solution lowers from 26 degrees to 24 degrees Celsius. Find the heat of dissolution. 2, molar heat of dissolution. 3, write the equation for the reaction. Number 4, draw an energy level diagram. Now, in this question, first of all, you want to identify whether this is an exothermic reaction or is an endothermic reaction. From the temperature change, starting from 26, that is, and lowers 24. Anytime the temperature of the solution lowers, or reaction lowers, means that reaction is an endothermic reaction. And endothermic reactions are given a positive sign, or positive enthalpy. Therefore, this is an endothermic reaction. So if you want to find the heat of dissolution of the reaction, we are going to use a formula. Enthalpy change is equal to mass capacity delta T. First of all, let's look for the mass. Mass. We have 2 grams of sodium hydroxide. This is a solute that was dissolved. We don't use the mass of the solute, but use the mass of the solution. They were dissolved in 100 cubic centimeters. This is the solution we are going to look for mass. So 100 cubic centimeters, the density is 1 gram per cubic centimeter. That is the density of water, 1 gram per cubic centimeter. Therefore, the mass of 100 cubic centimeters is 100 grams. Then, our capacity is in kilograms. So we divide that to make them kilograms. That is our mass. Then capacity is 4.2 kilojoules per kilogram per Kelvin. Then our delta T is 26 minus 20, that is 24 minus 26, you get 2 degrees. You change that to Kelvin, becomes 2 Kelvin. Multiply by 2 Kelvin. When you do that, the enthalpy change becomes 0.84 kilojoules. 0.84 kilojoules. This is the enthalpy change for this reaction. And the enthalpy change is positive. Positive 0.84. Or you can even leave it this because a figure left that way is a positive figure. Then, once you get that, we go to the second question. We are looking for molar heat of dissolution. Molar heat of dissolution. First we find out moles of sodium hydroxide that reacted. You get moles by getting mass given divided by molar mass. Now our mass given is 2 grams. Our molar mass, the molar mass of sodium hydroxide, the molar mass is 23 plus 16 plus 1, that comes to 40. The moles are 0.05 moles. Therefore, when you dissolve 0.05 moles of sodium hydroxide, the enthalpy change produced is 0.84 kilojoules. What if you will dissolve 1 mole? If you dissolve 1 mole, it will be called X. So X is equal to 0.1 times 0.84 divided by 0.05. And your figure will get to be 16.80 kilojoules. Now, something to note here, the temperature should be put in, when you're recording, temperature should be put in 2 decimal points. 1 decimal point that is 0, that is 26.0. Very clear to note that. The temperature must be recorded in 1 decimal point, 24.0, 26.0. Then your molar enthalpy is 16.80 kilojoules per mole. Kilojoule per mole. Then that is our question number 1, 2. Number 3, you're writing the equation for the reaction. We write the equation for the reaction. This is how the equation will be. Sodium hydroxide, solid, you dissolve in water to get sodium hydroxide in aqueous state. That is the equation for the reaction. The last question will draw the energy level diagram. You draw the energy level diagram, which becomes this. This is energy in kilojoules. This is reaction path. This is sodium hydroxide solid. You get sodium hydroxide in aqueous state. This is our energy level diagram. And remember, this is an endothermic reaction, and if in an endothermic reaction, the heat is absorbed. That is why the arrow is pointing downwards. And how much heat is absorbed is 16.80 kilojoules per mole. That is the amount of energy that is absorbed. Hope you have enjoyed our lesson for today.